So hello students, welcome back to our video classes, and this is going to be the second last class of Is Matter Around Us Pure? Okay, so far we have learned so many things through these video lectures, and it's been quite some time that I am with you, and I think I have completed most of the topics that we have learned so far, right? Now the thing is, today we are, as I told you, I like to ask you, keep on asking you that I need your 100% concentration. I need your 100% attention in this video. Let me tell you, in this video, we are really going to discuss about concentration. So definitely needless to say, I think you can understand, like today, I definitely need 100% concentration today, right? Now, so far, if you have any doubts, I think you know what you have to do. If you have any doubts for the previous videos, and if you are, making some problems, they are making some problems for you to understand, you just write it on the forum, okay? Definitely, one of our teachers would definitely reach you. Now, I think you have watched all those videos so far, and today, before coming to this video, as I ask you for each and every video before starting them, like you need to go through the previous videos first, because this is a continuation video, and if you don't know about the previous topics, then it will be very much difficult for you to understand this part. Now, today we are going to start with the concentration of a solution. Apart from that, we are going to read about the mass percentage, the volume percentage, normality, molarity, and mole fractions. So today we are going to cover all the important topics. Let me tell you, all these topics that we are going to cover today, all these topics are there in our competitive exams as well. Whatever competitive exams you are preparing for, you are definitely going to get these type of questions from these things, okay? Maybe not directly, but what happens is they would ask you some questions where you need to work with these concentration terms. Think about yourself. Let's say this is you, okay, with a spike, okay? Now this is you. If you are working in a particular pharmaceutical industry, okay, this is your industry, okay? Now they are asking you to prepare a medicine, okay? Let's say you are a scientist and you are there to prepare a medicine. I am recording this thing in 2021, so right now I am like in the middle of Corona and all these things. Okay, so right now all our scientists are trying to prepare some antidote of that. Okay, so right now, if a particular scientist wants to make some antidote which is called A, okay, and his company has asked him to make this antidote, what you have to do is you need to add 3%, 5%, and 7% of three components, let's say X, Y, and Z. Only then this component A would get formed. Now, all this thing I have told you so far, like 3%, 5%, and 7%, or 3 volume, 5 volume, and 7 volume, these are called the concentration. Tell me, without these values, would you be able to form any antidote? Think about, like, let's forget about all these antidote problems and all. Let's just focus on simple cooking. I think you all know, like, in cooking, we need to put things in a particular ratio, in a proper ratio, right? Now, if I ask you to cook chicken or something like that, whatever you like, and if you put like about, what should I say, 3 to 4 spoon of salt in that, then definitely it is going to get weak, isn't it? So you need to remember that a proper amount, a proper concentration is always needed for a reaction. Okay. Now, to solve these questions with the concentration terms, we need to learn what are these concentrations now. So the mass percentage, the normality, molarity, all these things are going to help you to find out the concentration of a solute or a solvent or a solution, through which you can calculate several things. You can control the amount of product, you can control other things as well. Okay, so this part is very important. This has a very useful applications in practical life as well. Okay, so today's class is going to be the most important class. Let me tell you, whatever you have learned so far in this chapter, this is the most important part of this chapter. Okay, most of the questions you'd get from this part, and let me tell you, like near about 80% of the students are not having a clear idea about all these things. Okay, so today you have to be very much concentrated, right? Let's see. The first thing is, what is a concentration of a solution? A solution, let's just go through it first. A solution concentration is measured of the quantity of the solute that has been dissolved in the given quantity of solvent. So like if we just try to understand about it in a very simpler manner, what would you say if I just ask you what is a concentration? So you would definitely say, sir, if I just make some tea, okay, and if I put 2 teaspoon of sugar in it, and if I make another cup of tea with 1 teaspoon of sugar in it, then definitely the cup of tea with 2 teaspoon of sugar would taste a little bit sweeter than the other one, isn't it? So the concentration of salt or the sugar in that cup is more. So concentration is nothing but the measurement of the quantity of solute. So the sugar was a solute that has been dissolved in the given quantity of solvent. 1 cup tea, you are giving 1 teaspoon of sugar, okay, and another cup tea you are giving 2 teaspoon of sugar. So concentration is the amount of sugar you are giving it to the particular amount of solution. So you can see the concentration is written as the solute by solvent or solution. It can be both of them, okay? So amount of solute in a particular amount of solvent or solution. Okay, so the amount of solute, this amount can be denoted in so many ways, isn't it? Like we can denote it with respect to grams, or we can also denote it with respect to moles. We can also denote it with respect to kg. So we can take any of the concentration terms. We can take any of the terms which would help us to denote an amount, right? And if we just go back to this solvent part, now the solvent of solution, we can make it in liters, or we can make it in kgs or grams as well. Okay, so there are so many ways through which, so many units through which we can represent the entire thing, the concentration, by changing the like units of the solute, amount of solute, or by changing the units of the amount of solvent. We can do both of them, right? So depending on that, what unit we are taking, what is the what is the scale we are taking to measure it, depending on that only we have so many concentration terms. Okay, now we are going to learn about them one by one. The first thing is mass percentage. So this is the most the simplest one. You can see like mass percentage is the way of expressing the concentration or describing the component in particular mixture. Okay, now if I ask you, you have NaOH. Okay, you have NaOH. Now if I ask you what mass percentage from here, what percentage of sodium is there in 40 grams NaOH? If someone asks you this question, what percentage of a constituent of NaOH, which is sodium, is there in 40 gram of NaOH? Okay, so this is called mass percentage. So mass percentage is mass of solute by mass of solution into 100. Okay, so the thing is, in 100 gram of solution, how many grams of solute is there? That is called mass percentage. Okay, in 100 grams of water, in 100 grams of solution, how many or how much grams of solutes are there. Okay, this is called mass percentage. Fine. Now, if I ask you to find this out, would you be able to do that? Just try it yourself. Pause this video and try it yourself. It's a very simple question. I have 40 gram of NaOH. Okay. So in NaOH, I have one Na, I have one oxygen, and I have one hydrogen. So let's find out what is the entire mass of NaOH, molecular mass, or we can also say what is the molar mass of NaOH. So molar mass is coming like 23 for sodium. Sodium is 23. Oxygen over here, so mass would be 16, and hydrogen over here, the mass would be 1. So the value is coming as 40, isn't it? So one molecule of NaOH weighs 40 grams. Now they're asking what percentage of Na is there in 40 grams of NaOH. So in 40 grams of NaOH, I have 23 grams of Na. In 40 grams of NaOH, I have 23 grams of Na, isn't it? NaOH. So 23 plus 16 plus 1. So this 23 was there in 40 grams. So in 40 grams of NaOH, there is 33 grams of Na. Now they are asking what is the percentage of Na present in there. So what would happen for 100 grams of NaOH? So the value would be 23 into 100 so 23 into 5 by 2. It is coming like 5115 by 2 by 2. This percentage of Na is there, so you can just make it in decibel as well. This percentage of Na is there in 40 grams of NaOH. Okay, so what you have to do is to find that out, you have to find the molecular weight. After that, you have to see in that amount how much amount of each constituents are there. After, depending on that, you need to take the action. Fine. So 11115 by 2, that is going to be the percentage of sodium. Yeah. Yeah. Now we are going to learn about, that was mass percentage. So to find out mass percentage, what we did is the amount of solute in grams we need or kgs we need to, in 100 grams of solution, right? So like after that we can move on to volume percentage now. Now what is volume percentage? Okay, so the same thing is going to be here. Volume percentage is the measure of concentration of a substrate in a solution. It is expressed as the ratio of volume of the solute to the total volume of the solution multiplied by 100. So what is volume percentage? So in mass percentage, it was like the mass of solute by the total mass of the solution into 100. In volume percentage, what happens is the volume of solute by volume percentage. Okay, so volume of solute, the amount of solute. What are they saying over here? The measure the concentration of substance which is expressed in the ratio of volume of the solute to the total volume of the solution. Okay. Now previously it was the mass of solute in the total mass of a solution. Now it is volume of the solute in the total volume of a solution. Fine. This is called volume percentage. So the same question may come in different phases with different phases. So you can see like it can come in that way, like the volume of solute and volume of solution, right? So they can ask you a question like, I have 10 liters of NaOH, okay, in 100, okay, into 100. As it is a percentage, we need to make it into 100, right? In 100 liters of NaOH solution, okay, 10 liter NaOH in 100 liters of NaOH solution, not solvent, okay. What does it mean? It means 90 liters of water, okay. It means 90 liters of water and 10 liters of another water, okay. Only then it can make it to 100 liters of NaOH solution, okay. Now if you look at it like the question comes like, if I have 10 liters of NaOH in 100 liters of NaOH solution, then what is the volume percentage? It is definitely going to be 10%. 10 liter NaOH is present in 100 liter of solution into 100. So 100 is going to get cancelled out. Put 10 over here, 100 cancelled out. So what would happen? The 10% would be the answer. Fine. This is how you are going to find out the volume percent. Don't worry about it. We are going to solve so many questions regarding this. So definitely at that moment, it would be very much simpler for you. Okay. So, so far, let's just quickly revise it all. So first, we have learned about the mass percentage. So in the mass percentage is the mass of solute present in the total amount of solution. So the mass of solute plus the mass of like in solution. So mass of solvent plus solute together. Okay. And this was the first one. And the second one was a volume percentage, right? The volume percentage was the volume of solute by the volume of solution. That was it, right? Clear? Now we will go on to the next. So now let's continue again. So this was all about the volume percentage and the mass percentage. So I think you have got it. Okay. Now you can see some of the pictures over here. They are writing like 20 ml. Like in this picture, there are so many things that you would not right now you would not be able to know. But after this class is over, you'd be able to understand whatever it is written in this picture. Okay, something like 0.6 mole acid. There is something like capital M. Now, what are these things? Okay, so this is our next topic that would start with normality. Now, what is a normality? Okay, so the normality is denoted by is equals to weight of a solute. Okay, you can say like the gram molecular weight as well. Okay, so what I weight by here, weight what I mean is the gram molecular weight, okay, or the molar mass, okay, by the equivalent weight okay of the solute into volume of the solution into 1000. Okay, fine. So right now, you know what, like in this way, if you just try to remember it, it would be very much difficult for you. So I would rather try to modify this equation a little. I would rather say you just remember it like in this way, that the equivalent, that the gram equivalent weight of the solute, okay, So you need to find out the gram equivalent weight of the solute first. Now, which is getting mixed, which is there in 1 liter of solution. Okay, just modify the denominator part again. This goes on like in 1 liter of solution. Okay, so the thing is gram equivalent weight of the solute present in 1 liter of solution. That is what called normality. Okay, stay there. Now, first is what is gram equivalent weight? You need to understand that, right? What is a gram equivalent weight? Look, you can see, like, if you just go through all the books, there would be so many ways through which they are trying to make you understand about the gram equivalent weight. But let me tell you, I have a very short trick through which you can understand what is a gram equivalent weight. Okay. Now, what would you do is you just write it like the gram equivalent weight is the molar mass, or you can say the molecular mass. Okay, the gram molecular mass. Okay, by the valency. So there are so many tales, so many books where they are writing it like an n factor. Okay, but let me tell you, just write valency. It is for your understanding. Okay, there's a trick through which you can find that. So whatever question is given to you, if you just want to find the equivalent weight of that particular substance, what you have to do is you have to write the molecular mass or the molar mass of that substance by divided by valency of that substance. Okay, so let's just get some example of that. Now, if I ask you over here, if I ask you, tell me what is the gram equivalent mass of calcium, what would you do? So it would be like the molar mass of calcium. What would be the value? It would be 40 grams, isn't it? The gram molecular mass, it would be 40 grams for calcium, remember? So for calcium, it is coming 40 divided by its valency. Now, what is the valency of calcium? The valency divided by valency. Okay, you'd be able to find it like there are so many books, they are writing like n factor, but I am writing valency to make you understand about it, so it would be easier for you to understand it. Okay, we don't call it valency, but this is the way through which I would suggest you to find these questions. Okay, to solve these questions. Now, 40 grams by valency. Now, what is the valency of calcium? The valency of calcium is 2. So the equivalent weight is coming as 20 grams. 40 divided by 2 would give you 20 grams. So the gram equivalent weight of calcium is going to be 20 grams. Simple. Now, if they ask you that what is the gram equivalent weight of nitrogen, then what would you do? Okay, the first one is find out. So gram equivalent weight is equals to molecular mass or the molar mass. So for nitrogen, the molar mass is 40 grams, right? 14 grams divided by its valency. What is the valence of nitrogen? It is 3. So 14 by 3, this is going to be the equivalent weight of nitrogen. Okay, now moving on to next question. So this was like the atoms. Okay, this was about the atoms. Now let's find out what is the equivalent weight. What is the gram equivalent weight of H2SO4? Now we are moving on to an acid. So for the atom, molecular weight divided by its valency. Now when we are moving on to the acids, So if you have to find the equivalent weight, first thing is you need to find out the molar mass. For H2SO4, let's find that out. For H2SO4, which is coming, for H2SO4, it would be hydrogen 2, sulfur 32, 2 hydrogen was there, right? One each for each, or one of each one of hydrogen. Now we have 2 hydrogens, so you can see like I'm writing 2 directly, right? Now, and the sulfur, and there goes the oxygen. So I have 4 oxygen. One oxygen is 16 grams. I have 4 oxygen. So from here, if you just add them up, 32 plus 64, it would give you 98 grams. This is the molar mass of H2SO4, right? Now you just write it, 98 grams. The molar mass is done, or the molecular mass, gram molecular mass is done, divided by its valency. Now tell me, for an acid, what do you understand by the word valency? For an acid, like if there is an acid, what do we call an acid? Like which elements are called acid? Those who gives up electron, gives up hydrogen, right? So the element that can give, like for H2SO4, how many hydrogen can be given up by one H2SO4? So this is going to be 2. One H2SO4 can give up 2 hydrogen. How? If you just break it down, you'd get 2H plus and SO4 2 minus, isn't it? So one H2SO4 can give you 2 hydrogens, right? So the valency of H2SO4 is going to be 2, right? So if we just write 2 over here, then it would come 49 grams. Fine. So the valency for acid or for bases is the amount of hydrogen or OH minus it is giving in that reaction or in that solution. That is its valency. Fine. So I will not move after that, because after that, which is coming as the equivalent weight for the salts and different types of reactions as well, the redox reactions. So those are not there in your syllabus. Okay. So the most important thing is how to find out the equivalent weight for the acids and for the normal atoms. Okay. Now, after learning this, now let's just go back to normality. Normality, they are saying that the gram equivalent weight of the solute by 1 liter of solution in. So when there are like the number of equivalent weight, there is some number like X number of equivalent weight of a solute, of a particular solute is there in 1 liter solution, then we call it 1 normal. Okay, let me tell you. Like, let's just go through one example. See to it. Yeah. Let's just go through an example. If they ask you a question like, I have 40 grams of NaOH in 500 ml of water. Okay. Now you need to tell me what is the normality. Okay. You need to tell me that. Now focus on it. Whenever you get a question like that, my tip is write the formula first. It would help you a lot. Okay. Write the formula first. Normality equals to gram equivalent weight of the solute present in 1 liter of solution. Fine. So first, one by one, you need to find the numerator. Focus on that first. After that, we will be focusing on the denominator later. Okay. Let's just go to one by one problems. Okay. So first, we need to find out how much gram equivalent of solute is there. Okay, 40 grams of NaOH. You need to convert this 40 grams of NaOH into gram equivalent. Okay, how to do that? First, for NaOH, I'm doing this here. Wait for a moment. So for NaOH, let's find out the gram equivalent. You tell me what is going to be the gram equivalent weight. You know it already. Just pause this video and after that, try to figure it out. For NaOH, you need to find the molar mass first. For NaOH, it is coming like, look, for Na, it is 23. For oxygen, it is going to be 16. For H, it is going to be 1. Together, it is going to give you 40, isn't it? So for NaOH, it is 40 grams by its valency. Now, this is a base. Now, for the bases, the valence is going to be the number of amount of OH it is giving. NaOH can give only one OH, isn't it? NaOH is a monobasic acid, sorry, a monoacidic base. So it can give you only one OH minus, isn't it? It can give you only one OH minus. So its valence is going to be 1. So 40 by 1, and its equivalent weight is going to be 40. Right? Now 40 gram NaOH equals to 1 equivalent NaOH. 40 grams NaOH equals to 1 equivalent NaOH. Agree? Agree up to this? 40 grams NaOH equals to 1 equivalent NaOH. Now, I have 40 grams NaOH. So that is equals to 1 equivalent NaOH now. Right? So the first term is done. So I know how many gram equivalent of solute is there. Okay, the first part is done. Now we need to focus on the second part, the denominator. We have to make it 1 liter solution. But they are saying this 1 equivalent of NaOH is present in 500 ml. Okay. So in 500 ml, there goes 1 equivalent of NaOH. So the normality of a reaction would be, okay, by the way, normality is denoted by capital N, right? Capital N. So normality of the reaction would be, of the H2 NaOH would be 1 gram equivalent, okay, EQV, in 500 ml. Now 500 ml means how much liters? 500 ml means 500 by 1000 liters. This is the conversion factor. 1 ml means 1000 liters. 1 liters means 1000 mLs. Okay. I have 500 mLs. That means 1000 liters. What am I saying? Just wait for a moment. Forget about it. Getting it, the conversion factor is all okay. Okay. Whatever I was saying is wrong. The conversion factor was all okay. Whatever I've written. So 500 ml I have, right? So that would be 500 by 1000 liters. 500 ml means 500 by 1000 liters. Let's make it simple. 500 ml means half liters, isn't it? 1 liter means 1000 ml. 500 ml means half liter, right? That is how it comes. 500 by 1000. Okay. So now what is the value coming? 1 by 1 by 2. So the value is coming 2. Right? So this is how you can find out the normality. So the normality of the solution is 2 normal, 2N. Fine. So this is just focus on the approach through which I got the answer. First, focus on the numerator. Try to convert it first. And the second work is look at the denominator. After that, try to convert it one by one, right? Whenever they ask you these type of questions, first write the formula in like and any other places, okay? And after that, focus on one by one of the problems. Now, in that way, you can find out the normality of the solution. Clear? Now, right now, we are going to discuss about the molarity of a solution. So in molarity is denoted by capital M, which you can see over here. The molarity is pretty simple. This is not that difficult like normality. If normality was difficult to you, molarity would be half of that. Okay. Now, wait for a moment. Yeah. Now, what is molarity? Look at the name first. Molarity. So molarity has something to relate with moles. Molarity has something to do with moles, isn't it? Now, if I tell you what is molarity, let's try to understand the formula of molarity. Now they're saying like the number of moles of solute. The number of moles of solute. Previously, it was the number of gram equivalent weight of the solid, right? Now it is coming to moles, and the name is molarity now. Okay, so from there you can understand, correlate them. Molarity means the number of moles of solute in how much amount of solution? 1 liter of solution, like it was previously. So 1 liter of solution. 1 liter of solution means solute plus solvent. Together it's giving you 1 liter. Are you getting this point first? First tell me. Like if this is a beaker of 1 liter, then first put solute A in it. After that, so there is a mark of 1 liter in there. Okay. First put the solute A over here. After that, put water or whatever you are going to give it. Together, they are going to make it a 1 liter. Together. Okay, if the solute is in, like, let's consider like it is of 100 ml, the solute is 100 ml, then the solvent would be of 900 ml. Overall they would become 1 liter. Clear? That is the point. Now molarity is the amount of substance in a certain volume of a solution. So this was very simpler way to express it. So actually the number of moles of solute in 1 liter solution. Okay, now let's go to question. Let's try to find a question. Find out the molarity of the solution containing, let's say, 30 grams of urea. Now you need to find out a molarity of a solution which is of a 1 liter solution which is containing 30 grams of urea. Okay, let's find that out. So as I told you before, when you get this type of question, the first thing you are going to do is you are going to write this equation first. Right, you're going to write this equation first. After writing this equation, what you have to do is just try to figure out one by one. Okay, first the numerator, number of moles of solute. So in whatever unit the solute is given to you, you have to convert into the number of moles. Fine. The molarity of a solution containing 30 grams of urea. Now the work is you need to convert 30 grams of urea into its moles. Clear? Now urea is NH2CO NH2. This compound is called urea. Okay, this was the first organic compound synthesized by German scientist Wohler. Okay, whatever. So this is urea. So for urea, the molecular weight, let me see, the molecular weight is going to come 60 grams. Okay, the molecular weight is going to come 60 grams. Okay, now I have 30 grams of urea. My work is converted into moles. So if someone asks you, I have 60 grams of urea. Okay, wait for a moment. I have 30 grams of urea. Okay. Then what is the number of moles of urea? What would you do? You'd say like moles is equals to quantity by difference, isn't it? That is how I taught you about moles. Quantity by difference. Now, to find out the number of moles, what is the quantity? 30. What is the reference through which you are calculating it? You are calculating with respect to the mass scale, right? So according to the mass scale, 60 grams equals to 1 mole, right? It is making like 2 q by r, 1 by 2 moles, 1 by 2 moles or 0.5 moles. So 30 grams of urea means 0.5 moles. Now, the first work is done, isn't it? Then how many number of moles of solute? I have 30 grams. I have successfully converted into moles. So that is half moles of solute. Okay. Let's say molarity would be half moles divided by half moles divided by. So this half mole should be present. So let me see how much amount of solution was there. There was 1 liter solution. Okay. So the denominator is already set. So the thing is, this 1 by 2 moles of solute, 1 by 2 moles of the solute is present in 1 liter solution. It's present in 1 liter solution. Okay. So the molarity would be half. Fine. This is how you can find out the molarity. Now, if someone asks you what is the relation between normality and molarity. Now, to understand this, when someone asks me this question, now to understand this, what I do is I just do a mind work. For H2SO4, if I try to think about it, molarity is number of moles present in 1 liter solution, right? Molarity is number of moles present in 1 liter solution. Normality is number of gram equivalent present in 1 liter solution. So one is mole, another one is gram equivalent. No? For H2SO4, the molar mass, for H2SO4, the molar mass is 98 grams. So when 98 grams of H2SO4 is there, when 98 grams of H2SO4 is there in 1 liter solution, in 1 liter solution, then we call it 1 molar solution. Then we call it 1 molar solution. Fine. Now, in the similar way, what do you mean by 1 normal solution then? So 1 normal solution is gram equivalent weight. Now you have to divide this 98 by its valency, which would be 2, and it is coming like 49 gram H2SO4. It's coming as 49 gram H2SO4. Now, this 49 gram H2SO4, if they're in 1 liter solution, they would give you 1 normal solution. Clear? So this is what this normality and molarity is. So they say, so what is the difference between them? What is the difference between them? 1 molar H2SO4 solution, 1 molar H2SO4 solution stands for 2 normal H2SO4 solution. 1 molar is equals to 2 normal. Clear? So this is how you can find that out. Okay, because the normality, in the case of normality, the molarity is the moles is getting divided by 2, or like what is the valence is there. Okay, this is how you can find that. Okay. So that was all about the molarity, normality, and all these things. Now we are going to talk about another very important concentration term, which is called molality. So here everyone gets confused. Okay, I would strongly suggest you, before watching this part, just revise all of them once. Okay, after that, solve some of the questions for normality, molarity, and the concentration terms like the percentage and all these things. First, read them out. After that, solve some questions. So until and unless you feel so much confident about it that you can learn about molality. Okay. Now, what is molality? I'm just telling you. Molality is, again, you can see there is a word called mole over here. So just write number of moles for molality of solute, number of moles of solute for molarity in 1 kg, not 1 liter anymore. Now it has become 1 kg. Okay, solvent only, not even solution. So in 1 kg solvent, there are two tricks. One is 1 liter is getting converted into 1 kg, and the second trick was the solution is getting converted into solvent. So molality is the number of moles of solute which is there in 1 kg solvent. That is called molality. So before starting this part, I'm just strongly suggesting you pause this video, watch this or watch the things all over again. After that, start this part, solve some questions before coming to this part. Okay, so now we can, I think, as you have completed all these things and I think you have revised it again, so now we can continue with this molality part. So the thing is, number of moles of solute present in the number of, wait for a moment. Yeah. So the number of moles of solute which is present in 1 kilograms of solvent. So what are the things that is getting changed? Focus on here. First is 1 liter is getting changed by 1 kg. Clear? Now, the second thing that got changed is solution got changed by only solvent. Okay. So 1 liter of solute present in 1 kilograms of solvent, not solution anymore. Mark my words over here. Okay, this is the main thing where everyone makes a mistake. 1 liter is getting changed into 1 kgs, 1 kilogram or 1000 grams, and solution is getting changed with the solvents. Okay, so in that way you can find out the molality. So molality is defined as the total moles of solute contained in a kilograms of solvent. Okay, that is how you can find them out. So like the way we have discussed about molarity and the normality. So if a question comes in that way as well, you can find it like the what would be the molality as well. Okay, so now I think we have discussed about all these concentration terms so far. Okay, now what you have to do is you would have to practice these questions. Okay, questions from these parts. I have already told you about a little about this concentration terms and all, but let me tell you, this part is all about your practice. More you practice, more you would be better about it. Okay, so you need to keep on reading these things and practicing the questions from these parts. So let's just start with one question, which is we may say it is not a frequently asked question, but this question is going to make your concept very much clear about it. In the following reaction, calculate and find the normality when it is 1 molar H3PO4. Now, look into it. They are saying that 1 molar H3PO4, 1 capital M in the bracket, right? So 1 molar H3PO4. And after that, they are asking you how many normals of solution is there. Okay. What is the difference between a molarity and a normality? So look, most of the people just forget, just get confused about it. But I have told you to remember that to memorize. You don't have to, try. You don't have to try to memorize it. What you have to do is you just need to memorize one example of it. Most of the time, if you just try to memorize it, it would, you would get confused about it and you would make the silly mistakes. You just remember this one example of H2SO4. So what happened to H2SO4? The molecular weight of H2SO4, or the molar mass, or the gram molecular mass, whatever you say, was 98 grams, isn't it? You just calculate it all over again, it would be coming as 98 grams, right? When 98 grams of H2SO4 was there in 1 liter solution, 1 liter solution, solute plus solvent, then we called it 1 molar solution. When 98 grams, which is equals to 1 mole, when 1 mole means 98 gram H2SO4 was there in 1 liter solution, we called it 1 molar solution, isn't it? Now, when 49 grams, when 49 grams of H2SO4 was there in 1 liter solution, we called it 1 normal solution. This 49 gram is equals to 1 gram equivalent of H2SO4. Clear? So 98 grams, that gives you 1 molar solution. 49 grams gives you 1 normal solution. So when you are taking the exact molecular mass, that is giving you the molar solution. When you are dividing it with the valency, that is giving you the normal solution. Okay. Now over here, 1 molar H3PO4 solution was there for you. 1 molar H3PO4 solution was there for you. Now, okay, it would be not H3PO4. Okay, I've just changed it in the PPT. It would be H3ASO4. You need to find out the value of H3ASO4, right? Now look at this equation. H3SO4 is reacting with NaOH to give you Na2HASO4 plus H2O. Now let's try to find out what are they trying to say over here. Look, H3ASO4 after reacting with NaOH is giving you Na2HASO4, which means 2Na plus HASO4 2 minus. Clear? HSO4 2 minus. Now focus on it. H3SO4 is turning into HASO4 2 minus. How many hydrogen is it giving in the process? It is donating 2 hydrogens. H3 is converting into H. So it is donating 2 hydrogens. I know there are 3 hydrogens which can be given up by that ACE, but in the reaction it is giving up 2 hydrogen. So in that particular reaction, it is showing the valency of 2. Okay, in that particular reaction. So whenever they're giving you the reaction, focus on that. They're trying to tell you something. In this reaction, ACE is showing you the valency of 2. For this question, whatever molecular weight would come, if you divided it with 2, then you would get the gram equivalent weight. Then you would get the gram equivalent weight. Clear? Molecular weight divided by 2 would give you gram equivalent weight. And so 1 molar HASO4 minus HASO4 solution. So the solution was 1 molar earlier. The solution was 1 molar. And they're asking you how much normal is that. Okay. Now, if I tell you that 1 molar equals to X gram of HASO4, if you just add them up, you can find the value, but you don't have to find that. What I'm saying is, if you say that 1 molar H3ASO4 equals to X grams, okay, so X gram is present in 1 liter solution. Okay, then this is going to be 1 molar. Got it up to this? Now for 1 normal, what would be the value? X by 2. When X by 2 was there, that is going to give you one normal solution. Tell me, clear up to this? X grams, 1 liter solution. X by 2, because the equivalent weight is going to give you one normal solution. Okay. Now, I'm just writing it all over again. Don't look at the answer right now. Okay. Just focus on how am I getting it. X gram is giving you 1 molar solution. X by 2 grams are giving you one normal solution. Clear to this? Okay. Now, we have X grams. We have 1 molar solution. Then how many normal solution do I have? X by 2 gives us one normal solution. So X gram would give me 2 normal solution, isn't it? Got my point? X grams is giving you 1 molar solution, right? X by 2 gram is giving you one normal solution. So X gram is giving you 2 normal solution. So 1 molar equals to 2 normal for this question. Okay, if you have understand this, then it's very good. You just otherwise you can just for try to memorize this equation, that a normality equals to molarity into number of equivalents. Okay, the equivalence is 2 over here, molarity is 1. You just put the values and you just get it. This is all about this is like when you are a calculator or when you are a robot, you just remember this and just put them in it. And the way I have taught you right now, that is the understanding with the concepts. Okay, this way you can understand it, and this way you can get the answer faster. Okay, now first I would suggest you first try to understand it. Okay, so that whatever the question comes, you will be able to solve them. After that, try to memorize it. Then what would happen is you would have both the things. If the question is, if you have to answer faster, then you just apply on that. And if you have to understand the question, if the question is very difficult, if you have to understand it, how to solve this question, then you would go in this way. Clear? Now, moving on to the next one. What is molality used for? So the thing is, what was molality actually? The moles of solute, present in moles of solute present in 1 kg solute, 1 kg solvent. Okay, for normality and molarity, in both the cases, the denominator was 1 liter solution, isn't it? You remember 1 liter solution? But in case of molarity, it is 1 kg solvent. Now, let me tell you, in most of the cases, when we are doing something in our lab and all, we try to use this molality term only. Let me tell you why. Because molality is independent of temperature. Just remember this thing, okay? Why? Don't have to remember, just try to understand it. Independent of temperature. Why is that? Because you can see moles of solute, this is mass. Okay, this is not going to change with the temperature, right? And 1 kg of solvent, this is again mass. So mass is independent of temperature. That's why molality is completely independent of temperature. But if you just try to think about normality and molarity, both of them contains 1 liter solution. So 1 liter is nothing but the volume. Now, volume is very much dependent on temperature, right? If you just increase the temperature, the volume will increase. If you just decrease the temperature, then the volume will decrease. So normality and molarity, they would change with the temperature, but molality remains constant. Molality is favored by concentration transmission approach because of the solution of the mass solvent do not change with temperature. So this is the exact thing about it. Okay. So I think you've understood all about it, and I think the class was interesting for you. If you have any doubts, you just write it on the forum, and we would get back to you. And that's it for today. And thank you for learning with me, and keep learning with Ask IITians. See you soon. Bye for now.